agricultural engineer with the Ontario Ministry of Agriculture, Food and Agribusiness. And it's my pleasure today to be interviewing Matt Lensink from CEM Engineering. So Matt, thanks for being here. Tell us a little bit about yourself and CEM Engineering.
Yeah, thanks, Jake. It's an honor to be here. I am a mechanical engineer by training, but my mother grew up on a dairy farm between Drayton and Arthur, and so excited to be chatting with progressive dairy operators today. And I have taken over the family business, which is an engineering company, and so we help clients with the design and implementation of projects, primarily in the energy transition space. So whether that's power generation, biogas, renewable natural gas, hydrogen now, that's really what gets us excited every day.
Awesome. So tell us just a little bit about the journey of where your company started from in biogas and then where you see the marketplace right now, just sort of that breadth of where things have been and where they're going.
Yeah, so our company was founded 23 years ago by my uncle, and his background was in natural gas fired power generation, primarily for large institutions, hospitals, university campuses, and also for large industry, food and beverage, pharmaceutical, automotive. And in about the 2005-2006 timeframe, he really started to wrestle with the cost of natural gas, which was very high. It was $10 a gigajoule back then. And he was struggling with, what to do, because that was the source of a lot of his business. And so he was visiting our relatives in the Netherlands on the Dutch-German border, also dairy farmers on that side of the family. And they said to him, you got to see what these German companies are doing, literally 20 kilometers across the border. And so he got exposed to biogas technology that was being used on all these dairy farms in 2004, 2005, 2006. And for him, the light bulb went on. And so he went through a journey of trying to select the best technology for him to bring from Europe. He believed that the Europeans had a good technological solution, but it would, how do we implement it in North America? Ultimately, he forms a relationship with a company called Plan ET Biogas, and he becomes one of the partners in what became Plan ET Biogas Solutions, which is a going concern here in Niagara and all across North America in the biogas industry. They're a technology provider and an engineering and a construction company. And so that was kind of our initial journey. And then we kind of, that was released onto its own. And since then, we've been involved in the engineering and project development and construction of wastewater biogas to electricity, most notably in Chatham, Ontario. We've done a lot of work in landfill gas to renewable natural gas. So taking all this gas that's produced in these landfills and cleaning it up to pipeline quality gas. And then most recently, we've been seeing biogas to electricity projects come back around again. In the Plan ET days, and when I was very active in the feed-in tariff days, 2009, 10, 11, it was all biogas to electricity. Then it's been biogas to renewable natural gas. And now we're seeing the pendulum swing back, I think, to biogas to electricity.
Right on. So tell us a little bit about, just walk us through some of the players in that electricity marketplace, where the contracts will be coming from. There's a bunch of acronyms and all that, but just kind of tell us, looking in the next 5 years here in Ontario, what does that electricity marketplace look like? And then secondly, after that, we'll talk about what does it look like on farm? How will people participate? So let's just talk generally about the market and the players and the names and some of that.
Yeah, to set the context, which is broader than broader than Ontario, but it applies to Ontario as well. I look at the energy transition that we're going through, whether it's on the molecules side of the world with gas and liquids, or on the electrons side of the business. We have to think about kind of the three-legged stool, and the first leg is sustainability. What is the carbon impact to how we generate and use our energy? The second is affordability, right? We want to make sure that the energy we have is affordable. And then the third is reliable. We need to make sure that when we want the lights to turn on, that the lights turn on. So we always have to, I think, be balancing this issue of sustainability, reliability, and affordability. And so with that context, then we can kind of zero in on the Ontario electricity framework. And what we're seeing in the Ontario market and the Independent Electricity System Operator, or the IESO, just published a report. Here we are in the kind of middle of October reporting this. They just published their forecast of load. So the job of the IESO is kind of twofold. One is to make sure that minute by minute, all the lights are on and all the loads are served across the province. That's number one. Number two is long term, are we going to have the electricity we need to meet the loads in the province? And so they're thinking about what's the generation we have, whether it's nuclear power, whether it's wind, solar, biogas, biomass, hydroelectric. What sources of electricity do we have? And then what's the consumption going to be? And so the recent report that was published increased yet again their forecast for load growth in this province. And what's driving that is a bunch of factors. We're seeing a lot of big industry convert to electricity. One of the big ones is steel making is converting to electric arc furnaces instead of coke oven, as an example. That's a big load. We hear a lot about the electric vehicle, the EV supply chain. And so those manufacturing facilities, particularly in Western Ontario and in Windsor and Tillsonburg, those facilities are going to have a big load on the province. EV charging, charging of electric vehicles, and then electrification, moving a lot of our heating to electric heat, and other industrial growth, and then data centers is kind of the latest one that's been added to the load. So the forecast for the load is, every time they publish this report, the forecast seems to go up and up and up. And there's really two elements to that, meeting that future load. There is what they call demand, which is what's the peak kind of consumption on a hot day or a cold day. What's the peak consumption across the province when we all have our air conditioners on and things of that nature. So that's demand. And then there's also energy. So over the course of the whole year, how many kilowatt hours are consumed? And both of those forecasts continue to go up. And so the IESO, the Independent Electricity System Operator, with their second job, they're looking ahead saying, uh-oh, we got this big load growth. And politically, the politicians are saying, we need to figure out how to do that in a sustainable but affordable and reliable way so we can continue to bring industry into Ontario. And so the IESO is at the center of this, really trying to figure out how are we going to meet this load in a sustainable way that's reliable and affordable. And so they're running a series of programs to acquire new generation. And they're also looking at nuclear. They're looking at repowering or the existing facilities, extending or expanding them. So yeah, there's a lot going on, probably more than we've seen, certainly in my career here in electricity in Ontario.
Exciting stuff. So lots of demand potential, and the ISO is developing plans. What will it look like in the near term for a biogas facility? So we got a farmer who wants to build a digester, and they're thinking, is it renewable natural gas? Is it electricity? What do you foresee in the near term? How are people starting to play into that now?
Yeah, I think there's a couple elements to that. So first of all, in Ontario, we have a strong biogas base already, and the dairy industry has always been a leader in that. And so I think there's an element of those existing systems to either expand or to recontract and to extend the existing contracts that they have. And the extension of existing contracts is something that's early days with the IESO. It's still in conversation. There's a thought process. There's a program they're going to have to develop. But that's one mechanism, is how do we expand existing or extend existing assets. So that's number one. But I think what's also very exciting, whether it's the expansion of existing or building new facilities, there are a couple contracting approaches, contracting mechanisms that the IESO is either working on right now or working on in the very near term future. And so the one that is available right now, they're doing a series of what they call procurements, which is their fancy way of running a competitive process to engage in contracts that are both sustainable, reliable, and affordable for the electricity consumer, because that's who they work for. And so these are called long-term contracts, and they shorten it to LT. So they ran an LT1 program, and 2 biogas facilities were able to expand under that program. And we're now watching the LT2 program, which will be run over the next year, and looking at how can biogas play a role in the LT2 procurement as a fuel that is both, I think, very sustainable and should be affordable and dispatchable, so it provides that reliability component.
So our existing digesters in Ontario, they're 250 kilowatt, 500 kilowatt generally, some bigger, some smaller, and they basically run continuously. They're always generating power for the most part. And under this new LT framework, there's more like this demand, there's these peaks and so on. So can you talk a little bit about how a digester will look different in the future versus what they currently look like today?
Yeah, and so in some ways, biogas is this double-edged sword or triple-edged sword, which is a good thing, but it's also sometimes a little challenging to figure out the right path forward. What I mean by that is we have this great resource, whether it's feedstock residues, or it's animal manure, or it's food waste from different processing facilities. We really have all these resources that we can then convert to biogas. And so that's done through a process called anaerobic digestion. And when we have that biogas, which is 60% methane, 40% carbon dioxide, and some other stuff, then we can either burn it as we produce it to make electricity, which would be a continuous operation, as you point out. We can take that biogas and we can strip out all the contaminants like carbon dioxide and hydrogen sulfide and make renewable natural gas and inject it in the pipeline. In a lot of rural settings, that's difficult because the infrastructure isn't there. Or what we're seeing under the LT2 program, likely, one aspect of the LT2 program at least, is you can create that biogas and maybe dry it out a little bit and store it. And so then what you're doing is your biogas production will be continuous. So you'll always feed the feedstock into the anaerobic digester, and you continually produce biogas, but then you store it for the peak hours of the day between 11 in the morning and 7 p.m. when the load is the highest, and when the IESO needs, dispatchable generation. And so then you can draw down on that storage. And so I think we're going to see, more storage probably in kind of a compressed, like a compressed natural gas storage phenomenon. And that's really, I think, where biogas is well positioned. If you think about, today outside it's a sunny day, so the solar fields are making electricity. But think of at night or a non-windy day, you have these beautiful resources in wind and solar that aren't controllable. But we have this other resource in biogas that is controllable. And so there's advocacy going on with the IESO to make sure that that is appropriately valued in the program. And so that this dispatchability that provides the resiliency piece and the sustainability piece, it might be a little bit more expensive, but that needs to be valued in the program. So I think under LT2, that dispatchable piece will have a home. And I think the continuous operation energy play, I think, will also have a home. So yeah, I think there's some exciting pathways for biogas, and there's some exciting kind of financial incentives that are there as well for biogas right now.
Do you think biogas electricity can be competitive? So there's also battery storage, and that in LT1, in the first round of procurement there's a surprise, well, I don't know if it's surprising, there was a lot of battery storage that got contracted. So do you foresee biogas to continue to be economically competitive and have a pathway forward in the electricity marketplace?
Yes, for a couple of reasons. One, in the LT1 procurement, they split the procurement to energy storage and non-energy storage, which essentially meant natural gas or biogas. And so in LT2, the question will be, do they split them, or do they incentivize runtime? So what I mean is, do they incentivize how long the facility can run? So you store for maybe 16 hours and you run for 8 hours straight. Well, a battery can't run for 8 hours, or the numbers would indicate it's incredibly cost prohibitive to run for 8 hours. It's not really sustainable. And so biogas has an advantage there. The question will be, how prioritized is that? Because on a dollar per kilowatt or dollar per megawatt, it is cheaper to build battery storage than biogas. But number one, do they value the longer duration? That has yet to be seen. We'll probably know that by Christmas time. Number two, energy storage as a battery only has one revenue stream. It's just that contract with the government. But in the case of biogas, we have tipping fees for any food waste that might be processed on the site. So that's a revenue stream that energy storage doesn't have. We have the clean fuel regulation in Canada, and there are some projects now that are looking at how can we have a pathway to sell credits into the clean fuel regulation. And some of the early indications are that that's 8, 9, 10 cents per kilowatt hour equivalent. And that's in addition to the contract with the IESO. And then the other exciting one, although it's not yet official, because it hasn't received royal assent at the federal level, but there's an investment tax credit for biomass to electricity. And that will provide a 30% refundable investment tax credit on the eligible capital of the project. And so that, if you have a project, just to use round numbers, if you have a $5 million, make the math easy on a Friday morning, $1 million project, at the back end of a project, you're going to get a $300,000 tax credit. So there's a bunch of things on the incentive side and on the revenue stacking side that I think make biogas to electricity, very interesting. And the reality is, back to my earlier point, the IESO needs a lot of power demand, and they need a lot of energy. And so the reality is they need everybody to help out here. And that will allow some of the projects that have maybe not as competitive as energy storage, they will also have a fair shot because the need is so great.
So you sort of alluded to some of these things are still becoming clear. And so for these electricity markets, there'll be multiple rounds of procurement. Each set of rules will probably differ in response to how the last one went, and so on. So we'll see what that looks like. Yes. The last question I want to get to before we wrap up is around the ownership of carbon credits. So that's the focus of this PDO tour. And so I want to what does it look like under FIT? There used to be the environmental attributes, and certain environmental attributes may have been part of the FIT contracts and others not a lot of clarity. How do you see that moving forward? Will a farmer have access to the carbon credits from the digester that they build, or who will own the credits, particularly on the electricity side?
Our understanding in the latest kind of wording and framework is that those in this procurement LT1, LT2, those credits stay with the producer. And so they're buying electricity because they have such a need. They're buying either capacity or energy, but they are not, in our current understanding of the wording, they are not buying the environmental attributes. Those stay with the producer, which is huge because that allows you to play in the clean fuel regulation and other emerging markets as well.
Awesome. Matt, this has been lots of fun. So much to talk about. We could have gone for a lot longer, but really appreciate your time. And we appreciate your sharing and the details here. And there's probably more conversations to be had. So thank you very much for this today. Appreciate it.
Yeah, thanks, Jake, and safe travels to everybody. And shameless plug, I run a podcast, Energy Radio. You can find it wherever you get your podcasts. We talk about this kind of stuff all the time. So safe travels. Thank you so much for having me. Have a great day, everybody.
Great. Thank you.
Thanks, Jake.